Right, so I guess we can begin the session now. Good morning and good evening to everyone, and welcome to the first concurrent panel session. And our panel will be on the topic of resource economics. And so today we have three speakers lined up, and the way we'll do is that since we have only three speakers, each speaker will get 15 minutes to present their paper, and then 5 minutes for question and answer sessions. Right, and I will keep track of the time, and once you have 2 minutes remaining, I'll just let you know. Right, and if you have any questions, please ask the question in the chat button, and I encourage everyone to ask questions, please, and I'll just pick out the questions and ask the speakers after they get done with their presentations. So with that said, let's begin our first presentation from Dr. Ari Katuwal will be presenting on biogas adoption in Nepal. It's easy. So
I just unmuted. Can you see my PowerPoint? Yes. You can?
Yeah.
Okay. So let me bring this to this, see what happens. No. Okay, good morning. My name is Hari Katuwal, and I teach economics here at the Tarleton State University. My research area is natural resource and environmental economics. Some of the topics I've covered so far: water, forest, a little bit of energy, wildfire. But today I'm going to talk about biogas adoption in Nepal, drivers and challenges. So this is kind of follow up to one of our other study that was conducted, I don't know, more than a decade ago. So in terms of technology, it's a pretty straightforward and simple. Cattle manure and agricultural waste, including human waste these days as well, are used to produce methane gas, and that is used primarily for cooking and lighting in Nepal. So first, it was introduced in 1955. That was more of an individual installation, but later, around 1992, the installation went significantly up. So far, I think until 2020, more than 432 household level small scale biogas have been installed. Although there are reports that suggest the potential is actually 1.9, pretty close to 2 million. And that is household level, again, small scale, 4 to 10 meter cube biogas digester. You can see the trend here. It's been consistently going up. However, it went down pretty significantly, actually, because of the 2015 earthquake. One of the key contribution is the share of biogas used towards clean cooking fuel specifically is going up. In addition to being one of the renewable energy source for cooking, study, including one of ours, so that it comes with a lot of additional benefits. Some of the examples are improved health, save time, especially for women for cooking, and fertilizer. The slurry can be used as a fertilizer, and data shows that it helps boost productivity of agriculture, crops and other vegetables. and also reduced fuel consumption if the households are using fuel wood. And it significantly also contributes towards reduced deforestation and greenhouse gas emission. And because of all these benefits, this, along with other, for example, micro hydro, I think we have wind, and then we have solar. This biogas is also considered as one of the viable options, and it has been promoted by the government of Nepal consistently. And we do have quite a few number of studies. However, most of the studies, primarily from Nepal, they focus on current state, production potential, and some of the benefits. But what I couldn't find, at least it's limited in terms of what are the drivers and challenges, what are the key factors, what are the key determinants that will impact the adoption and installation of biogas. And I just wanted to kind of, fill that gap. So what I'm doing in this study is using a household survey that was conducted in 2018. It's a pretty large survey, 50 selected district. It's a national survey. They didn't include Kathmandu, Bhaktapur, and Lalitpur because of other factors that are not related to biogas. And total number of household they included was 6,000 plus. However, I'm using only close to 3,000 because biogas is not usually applicable to mountain and Himalayan region. So I'm excluding those households. So from Tarai and Hill, and after excluding some of the other households where the biogas is not really applicable, I ended up using close to 3,000 households. There are quite a few studies again in terms of examining and analyzing the key factors that would impact adoption of biogas, not in Nepal, but other countries, for example, China, India, a lot of sub-Saharan African countries. So most of the study, they use common socioeconomic and demographic and institutional and infrastructure variable. Again, most of the study, they simply go ahead and yes, it's 1 and 0, and then go ahead and use a probit model to estimate. And that's what I'm doing as well. But at least I found one study to kind of give a theoretical justification that, yeah, some household would adopt biogas if utility derived from biogas is more than utility derived from other fuels. So based on that idea, you can do an estimate demand or inverse demand function and use probit model to examine determinant of biogas adoption. So most of the study, again, they use purposely selected sample. For example, they go to one community or one city, and they will identify some comparable household, and then use that data to examine, yes, those are the household because of these factors, they adopted biogas technology, others didn't. There is a benefit, of course, of using that kind of sample, but the sample I'm using is not purposely selected. It's a national household survey, and there is a benefit of using that as well. So, but for my study, I'm using national household survey, not purposely selected per biogas. A quick descriptive statistics of some of the variables that I'm using for this analysis. Of course, we have male-dominated household head. 85% is in Tarai, 75% is in hilly area. I'm not including mountain here again. Average is 0.78. That's 78% of the household head are male. Number of members in the household, 4.12 in Thorai, 3.76, 3.8. So pretty, comparable when you look at those mean of those demographic variables. One thing that stand out is I still need to figure that out, the water supply. The current variable I'm using is actually whether or not the household is actually connected to piped water. And it does make sense that in Thorai, it's 75%. In hill area, it's only 1%. So I'm still thinking about that, and I hope I will find additional information, will interpret that. Other than that, most of the variables are pretty comparable. And the reason I wanted to look at the Thorai and hill is the adoption process, installation process is different, because how much biogas you produce or how effective the digester depends on the temperature. So the effectiveness is it's less effective when you're installing in hilly areas. So I wanted to kind of capture that as well. Empirical estimation, typical probit model, of course, y equals to 1 if the household is using biogas is one of the cooking fuel, 0 otherwise. Based on the literature so far, I'm using demographic, socioeconomic, and institutional. I just created a group. One set of variable, I'm calling it demographic, for example, sex, household size, and age. And I have a second group, which is more of a socioeconomic, although it would be tricky to kind of differentiate between demographic and socioeconomic. But just for my analysis, I'm dividing into 2 different groups. So education level, the one I'm using is education level of the most educated member of the household. Financial assets, this index I created based on their bank deposits, if they have stock, if they have a bond, other assets. And one of the key variable, almost all, because that's the required variable, the cattle, number of livestock owned by the household, and land holding as well. In addition to that, a couple of institutional, and I call other because I have included the region as well in this category. So water supply, whether or not they have access to water supply, how far they are from the nearest market. So I call that access to the market, and of course, Thorai and hill. So I estimated 3 probit model based on those 3 different set of variable. So first one, I used male household and age, male dominant variable, of course, household size number and age. At least for now, I'm using continuous variable. So the only demographic variable that's significant and obviously positive is male. And then I included education level. As I said, this is education level of the most educated member of the household. So I also tried education level of the household head. That was not significant. I tried the education level of the most educated member. It seems like it's statistically significant. Financial assets, as expected, it is significant. I'm still going back and forth as far as land holding is concerned, because most of the other studies, they find that land holding is statistically significant. So in my case, it is not. I tried, land holding and land holding square. It was not significant either. So I'm going back and forth with, I do have access to what type of land holding. Is it vegetable garden or other? So I'm trying different set, but for now, it's not statistically significant yet. A livestock, another interesting variable. I do have number of cow, number of buffaloes, number of goats, sheep, poultry. But for now, I'm using only cow, buffalo, and horses and pigs. I'm not yet using goats and sheep, but the reason I'm not using is if I want to use, I have to make it cow equivalent or goat equivalent. So I'm still looking for that information. So even not using goats and poultry, the results suggest that number of livestock is significant. The one I'm using currently is actually if the household owns more than one livestock. My continuous one was not statistically significant, so I decided to use, well, what if is there going to be significant impact if they have more than one or only one? So that one is significant, although the number continuous variable was not significant, and it does make sense, which is positive and statistically. Water supply, again, if they're connected, because water, of course, is required to mix the cow dung. If they're connected, the likelihood goes significantly up. Access to the market, the index that I'm currently using is distance in kilometers. So negative and statistically significant coefficient does make sense. Further you are away from the market, the likelihood of you installing biogas goes down. And of course, the right, as expected, is positive because the likelihood of you adapting or installing biogas in the right is significant because of the region, because of the fact that it is more effective. And that's what we see. For example, based on my data of 3,000 households, approximately 4% of the household, they have biogas.
1 minute remaining, sorry.
Yeah, I'm almost there. We're good. Yeah. 4% is, whereas in Tarai, it's close to 7.5, and in hilly area, it's 3.5. So it does make sense that the Tarai is significant. Quick discussion. Based on at least my result, it looks like socioeconomic and institutional and infrastructure are relatively more important than demographic variable. Adoption in hills and mountain region, although not directly from my study, but what I see is the likelihood goes up in Tarai, meaning it's more effective in Tarai. So there are ways to modify so that it could be equally effective in hill area as well. Again, one of the other thing I found was, although in Nepal, we've already started using cow dung, including human waste, but because of the physical structure of the digester, I believe we're not yet using agricultural residues. So that would significantly improve the effectiveness as well as adoption process. So 1 minute, I'm done. Thank you very much. I'll be happy to answer any question.
Thank you, Arizi. Yeah, so we have a couple of questions over here. So let me read them out. The first one is, do you think biogas adoption helps to lower methane gas into the atmosphere? And what makes slurry more productive as a crop fertilizer?
So data shows actually we have that process already established. We are the biogas, actually we're making money by selling that credit, greenhouse gas emissions. So that answered the first question. It does reduce greenhouse gas emission, and the agency was actually selling that credit and making some money out of biogas installation. The second one was, although not part of my study, but again, when I was reviewing literature, one of the things that was suggested was when it is exposed, the slurry exposed to sunlight, it becomes less effective. So the suggestion from scientists is to actually, cover it up so that it's more effective.
Okay, thank you. And what do you think about household income and access to alternative energy sources like firewood? Does that affect biogas adoption or not?
Can you repeat that one more time, please?
Factors like household income. I'm guessing the question is, does household income affect biogas adoption and the prevalence of alternative energy sources, like you could use firewood, right? So does that impede? Yeah.
Okay, thank you. The first part is, yes, I would say income would be important factor. My result shows that financial asset is. I use financial asset because it was easier for me, because income was directly not available in the survey. But I'm still hopeful I will have some kind of index I can create and use that because the financial asset is highly significant positive. That indicates the income should be an important factor as well. The second is there is already established actually a couple of studies published in well-established literature, including resource economics, that suggest it does reduce the consumption of fuel, firewood, and it does reduce deforestation as well. Yes.
Okay, so there's two more questions. I'll just combine them into one. The
Sure.
first one is that, is biogas comparatively cheaper than hydropower and solar energy? And the second one is, I guess, just related to that, in Nepal, people are not really using biogas, right? Even if it might be cheaper, people are not using it. Why do you think the adoption is not as good for biogas in Nepal?
So my quick answer is the first part, is it less costly? I don't have answer to that specific question. The reason is biogas is still heavily subsidized, close to 50%. It's pretty expensive for common household to install biogas. And some research they suggest, although I was not able to use that, I would still would be super excited about that. Access to credit, whether they can take loan, can actually significantly impact whether or not you want to install biogas. So the credit, it does impact whether you have access to credit. But again, the first part, I don't know if it's cheaper than micro hydro.
Thank you. So we are done with the question, but I just have, I guess, one comment. I noticed that in your regression result, your age was not significant, right? But I wonder if you could divide your age into maybe a categorical variable, because probably younger people are more likely to adopt a new technology or different technology than older people, right? So maybe households less than 35 years of household age, the head of household less than 35 years, maybe they might be more likely to adopt compared to other ones. Or did you try that?
I tried two things. One, divide younger and old using median age. That was not significant. And I also tried age plus age square, you said, and that wasn't significant either. So it turns out it probably is not really significant. I tried all three, are linear, square, and categorical. None of them are significant yet. But thank you.
Thank you, Arizi. So I guess we'll move on to the second presentation. The second presentation is about remittances, right? Can remittances finance clean energy in developing country? And the presenters are Gazi, Hassan, and Sakib, and Sakib, right? So let's hear from.
No, thank you, Samrat. Since my co-author actually based in New Zealand, it's a very odd time for him. So I will just present the paper, on our behalf. Okay, so I'll try to share the screen. Let me see. Just bear with me. Okay, can you see the screen?
Yes.
Okay. All right. This is actually one of our preliminary findings that we want to share over here. And as Samrat pointed out, the topic is can remittances finance clean energy in developing countries? And we use actually a natural experiment, and I will explain why we adopted the natural experiment and instrumental variable approach for our study here. So if I consider the motivation of our study, let me see. Okay. Can you see the screen?
Yes.
Okay. All right. Yeah. I'm not sure like whether I'm having some trouble here. Okay. Just wanted to make sure I don't have the Zoom thing coming on the side. So anyway, the motivation came from the Sustainable Development Goal, Goal 7, affordable and clean energy, and focusing on the Sustainable Development Goal Target 7.1, which states that by 2030, ensure universal access to affordable, reliable, and modern energy services, especially for if you think about the low-income nation, low to medium-income nation we are talking about. So that is one motivation. Another one is related to I don't know, like Samrat, my screen got frozen, I think here. Let me see.
Oh.
I wonder what is going on. Maybe I will just try again. Okay, stop share and try again. Okay. Okay. Let me go back. All right. Yeah, let's see.
Yep.
All right, there you go. So that is the one. And the second one is, of course, the reducing inequality within and among the countries. And sustainable development target, if you consider 10.7 and 10.C, 10.7 states facilitate orderly, safe, regular, and responsible migration and mobility of people. So the focus over here is that migration aspect and the mobility of people. And target 10C, we're talking about by 2030, reduced to less than 3% the transaction cost of migrant remittances. So based on these two sustainability development goals, our intent is to see like whether we can transform these sustainable development goals into observable facts at household level. And first thing that came into our observation is there's several health risks persist in rural households in LDCs, least developing countries, especially among women and children, attributable to indoor air pollution from inefficient cooking practices using solid fuels or dirty fuels, one can say. And the second is in migrant household. In migrant household, 60% of total household income comes from remittances. And United Nations estimates show that 75% of remittances flows go towards immediate needs, but the other 25%, over $100 billion per year, is available for other purposes. So it will be interesting to see that connection, whether remittances can influence adoption of clean energy. So there's some anecdotal evidence regarding this migration based on United Nations study, Office of Development Institutes, that migration can contribute to improve access to reliable, affordable, modern energy services through higher incomes for migrants and the sending of remittances. There are also some business models in some countries which focuses on how to channel these remittances through making sure that they're utilized for clean energy adoption. One is in Haiti, there's ARC Finance, where it mobilized remittances for Haitian diaspora to finance clean energy and was successful in displacing dirtier fuels from the poor Haitian households. And there's a clean energy tech program in Ecuador, which is funded by International Fund for Agriculture Development. this TAKE program is to boost rural energy access to Ecuadorians households through this financial mechanism based on overseas remittances. And there's another one in Bolivia, which is known as Eco Bazaar, which marketed solar water heaters to Bolivian diaspora in host country and sold them to migrant families in the home country using a remittance finance mechanism. And again, they use this Nordic Development Fund to make sure this Eco Bazaar is adequately financed. So what is the mechanism then? Why, what is the connection we are looking of, for this research? So if we look at the literature, remittances income are invested in education and health. And if that is the case, then migrant households have more health capital than non-migrants and are also more productive. This is actually a paper by Taylor and Lopez and Feldman they found, and also there's some subsequent paper later on, we see this kind of trend. So focusing on these two findings, one could be considering that whether migrant households will be the more likely to substitute towards cleaner fuel type, treating dirty fuels as inferior goods to safeguard their health capital and productive capacities from the harmful effects of dirty fuels. So based on that, we are focusing on these two research questions. What connection, if any, is there between the pervasive health risk due to indoor pollution in developing countries and international remittance flow? It's a bit of like an exploratory type of research question. And the causal one that we want to focus here, in particular, do remittances from overseas migrants play a role in reducing household exposition to indoor air pollution by promoting the use of cleaner fuel sources? So for our empirical strategy, we used household level a cross-sectional study. The data gathered through interviews via enumerators using a structured questionnaire, and addressing the selection problem by providing an experimental measure of the impact of remittances on clean energy use. We actually focused on the liquefied petroleum gas. We also have actually data gathered for biogas as well, but we just focus on LPG for the time being for this natural experiment. And we'll explain why we went from natural experiment and also the instrumental variable approach. So this is the study area. Basically, we are talking about the coastal portion of the Bangladesh, so the southeast coastal area, the Bhola, Borguna, and Pituakhali. And we have a cyclone Roano landfall in that area, May 2016, and the data collected in November to December 2016. So all in all, we have 610 households surveyed, but interestingly, only 105 households had one or more overseas migrants. So you can see that we actually have a drastic reduction in the number of households when we're talking about remittances out of this total number of households. So looking at our regression equation of interest, here we are basically using a probit model for probability of using LPG for cooking. LPG, here we are just using this equation. It could be, of course, clean energy, as I said, LPG or biogas. We can also think about that option as well, but we just focusing on LPG at the moment. So if you can look at the equation, we are, since it is not directly observed, the LPGI star is a binary variable. If LPGI is equal to 1, when the household I uses LPG as a cooking fuel, and equals to 0 if LPG is not used. Or some, we are talking about basically the dirty fuels. This is, we're talking about fuel wood or even considering other options like dungs and leaves as well. So here, remit is the monthly average amount of remittances money the household I receives from overseas measured in local currency, and XI is a vector of household characteristics which are controlled for. And then we also have, the proposed mechanism that implies that the coefficient in the remit term beta 1 should be positive. So let me talk about now the endogeneity issue, and this is the reason I was talking about why we went for natural experiment and instrumental variable approach. If we consider this structure, that equation that I talked about, you can definitely see that LPG usage will suffer from endogeneity bias due to reverse causality and measurement error. You can think about the reverse causality coming from the decision to migrate and remit earnings is often driven by poverty and a dearth of economic opportunities in the home country. which tend to correlate with the household choice of energy for cooking. So if a household's underlying choice of a less cleaner fuel sources is positively correlated with the receipt of remittances, this will tend to bias downward the effect of remittances on clean energy for cooking. So this is one of the issues we are talking about, the reverse causality. And the other one is that the poorer households, one can imagine, because of their lack of exposure to that numeracy and also, sometimes the education level, they're prone to mismeasure the remittances received. And from an economic standpoint, the prevalence of underreporting and existence of systematic measurement error tend to attenuate the coefficient estimate of remittances, leading to downward bias. So to address this endogeneity, we went for this natural experiment approach and also instrumental variable. So under the natural experiment, we considered there's a cyclone Roano landfall, that then there's a household receiving remittances. There's a treatment group that is affected by the cyclone Roano, and there's a counterfactual or the control group not affected by cyclone. So natural experiment measures the average treatment effect of the differences in mean outcomes between units assigned to the treatment and the units assigned to the counterfactual or the control group. And for our study, we use a natural experiment linking plausibility of exogenous variation in local rainfall in 3 districts. In southeastern Bangladesh, interacted with the cyclone-affected households' distance to the nearest weather station. So we are using this instrument over here, the distance and the rainfall. And why we are picking the rainfall? Because the rainfall is directly related with the crop productivity in that region. There are 2 major crops over there, almond and ouse. And almond crop depends on the wet season, basically the June to September, the rainy season. And the ouse actually doesn't depend on that rainy season, they just rely on the dry season. So there are certain areas which have the almond crop and also there's the ouse crop. So we use this instrument, rainfall, to capture this as part of the instrument, because if the rainfall is low, the crop productivity will go down, and there is a remittance will increase to those households. If they have migrant member in overseas, they will try to send remittances to make sure this household is protected by that kind of income shock. So
you have 3 minutes remaining, Sakib.
Okay, all right, thank you. So let me go to this is the first, the equation. If I consider here the structural equation is the main interest here, where the dependent variable, as I said, LPGI is latent and hence not directly observable. And then we have the reduced form equation, which explains the variation in the endogenous variable remit in terms of strictly exogenous variable, including the instrument, the distance, as I was mentioning, and the rainfall that is excluded from the structural equation. And we use instrumental variables ProVit, IV ProVit estimator for our analysis. And consistent estimation is based on the assumption that the errors are independently at an identically distributed multivariate normal. And violation of this assumption requires cluster standard errors to control for the lack of independence. So we have clustered the standard errors by villages for our analysis. So let me go to the results quickly, given the time. So this is our summary stat, and you can see the LPG or cylinder gas for cooking. We have the fuel for cooking, dung and leaves for cooking. Then there's also another variable that I didn't report here, that biogas. We are planning to have go through that biogas adoption as well. Like we want to see what kind of results we get over there. Then we have the number of overseas migrant, as I was mentioning. Only 105 households reported they have overseas migrant, and number of years migrant living overseas. If you look at the variable and the standard deviation mean max, an average amount of remittances received per month over, it is also reported over here. This is the rainfall and remittances in cyclone affected migrant households, and this is for the first stage equation we are talking about. And this is the second stage with the regression results. So here we are just reporting the instruments, and we are also reporting the remittances influence. There are a bunch of controls we are not reporting in this table, since the focus is on the remittances and and how the instrument influence remittance influence the LPG adoption or clean energy adoption. So if you look at the results, we found out remittances in fact influence the clean energy adoption or the LPG in this case. And if you look at the instruments, we have the different instruments over here, and we see that consistently this is positive, and it shows that if there's a 1 unit increase, for example, if there's a 1 unit increase of remittances, clean energy adoption goes up by 0.7 unit.
We're out of time, Sakib. Maybe you want to wrap it up.
Oh, okay. All right. Sorry for the, I have some difficulty with the technology over here. So anyway, we also went for the health expenditure, and we went through that even health, if you consider the health expenditure along with the tap water, deep, interaction with the deep tube well and water filter health expenditure, sanitary, we can still see the remittances have that positive influence and significant influence over clean energy adoption. And then for the exclusion criteria, we actually make sure that all these, domestic income, food and housing expenditure, they are not significant. If you look at that, none of these variables in the controls, when we added these variables, they are not significant. So it also, serve the exclusion criteria or exclusion principle. So, and we also did for the dirty energy, and 75% of in our sample is dung and leaves, and 80% is firewood. And we check the validity of the results using the national experiment to test how remittance affect dirty fuels used by household. And we also found that rainfall-driven remittances reduce the probability of using animal dung and leaves as well as firewood. And my last slide, the conclusion. So the findings are more important for remittances literature. It shows a new function of remittances. Current understanding of household energy literature put more emphasis on non-economic factors, so such as taste, gender, as drivers of clean energy choice. We present robust identification that remittances and economic factor has a causal impact on the choice of clean energy. And from the policy perspective, we are talking about that if you consider this Bangladesh, since the study is done on the Bangladesh over here. So Bangladeshi migrants abroad should be targeted to market sustainable energy, which is sold at home to family using a remittance securitization mechanism. This will require developing a business model. So thank you. I'll start here.
Yeah, thank you, Sakib. So we just have 3 minutes remaining. I'll go very quickly. Can you discuss some policy implications of your study?
So here we are thinking about, based on our, like those business model, initially when I talk about those business model, maybe for Bangladesh perspective, we can think about whether we can come up with something similar to make sure, since we were able to establish that connection, that remittances does have an influence on the clean energy adoption while controlling for all those mechanism, that can influence the remittances, besides the remittances or the clean energy adoption. We established that connection. We are thinking about, okay, if that is the case, what kind of business model we can adopt with some sort of like public-private partnership, so that there will be more take-up of this clean energy adoption from the household perspective. And the household, like an incentivize, like an incentive, coming up with the policies that will that will incentivize the households to go for this clean energy adoption, through this remittance securitization process.
So the other one is you used, I think, district and rain variable for your instrument, right? And did you use only the interaction, or did you use that separately also in your first stage?
Can you repeat the question?
So the district and rain variable, did you only use the interaction variable, or did you also use it separately, district and separate rain variable in the first stage regression?
Now we use the distance and the rainfall. Okay.
Okay.
And basically we use that one, nearest, the distance from the household to the nearest weather station. Yeah, we just use that. Like we found that that would be more, makes sense, considering the literature, because if we just take the rainfall, we are talking about only the effects on the crop productivity and, and all those things, but we are also want to make sure how far away these households are from this nearest weather station, because of the information is also important part. So that's why we went for that interaction between the rainfall and the distance. Okay.
I guess one very quick question: what do you think about government subsidy program for renewable energy? Does that what does it look like? Did you include subsidies in your analysis?
No, for our survey, we actually didn't have that specific portion about actually government subsidies. In fact, in our study area, we don't have that kind of mechanism where the government is trying to provide subsidies for clean energy adoption. Not yet. That's why we are thinking about some sort of like a business model with public-private partnership, because government may not have the kind of sufficient budget to move forward with supporting for these entire villages or the households to adopt for the clean energy adoption in that specific area in particular.
Okay. Thank you, Sakib. So I think we'll move on to our last speaker now. The last talk is by Aashish, Chhetri and Lakpa Tamang, and the paper will be on urban water security in Darjeeling.
Thank you, sir. And, am I visible, sir?
Yes.
Oh, am I audible? Oh, okay. Thank you so much, sir. Thank you very much. Warm greetings to everyone, respected chairperson, dear participants. My name is Aashish Chhetri, and I am a research scholar at University of Calcutta. And so first, can I see? Okay, so and Dr. Lakpa Tamang is my supervisor, so I'm a PhD scholar, and this is a part of my PhD research work, and just a second, sir. Am I visible, sir? Hello.
Yes, you are. Yeah.
Okay, sir, and okay, sir, and my co-author, he could not join the session due to some urgent work. So today I'm going to proceed with our presentation. And our presentation is actually basically deals with the water security, and like the other presentation, it doesn't deal with any energy sources. So I hope you will see the presentation and research. So urban water security, and the topic of my research is urban water security in Darjeeling, Himalaya, India. And so to introduce the topic, so it is better to begin with the concept of water security. And water security is a dynamic concept, and as we can see, its definition and its conceptual framework is evolving day by day due to the addition of so many factors that controls the water security in urban areas. So water security basically deals with the availability of water in a adequate quantity and quality to everyone. And urban water security is slightly different than the general concept of water security, and urban water security is more specific to the urban areas and not with the rural or the national or regional level water security. And when we talk about the water security in Darjeeling, Darjeeling is a hill station, and it's a town which is located on the hilltop, and it is very difficult for the people to get access to the multiple sources of water like the rivers, wells and all, because it's a rigid mountainous landscape, and it is very difficult for the people to fetch water from the river or to dig wells and to collect water. So the people are they are bound to depend on the locally available water sources. And so the main factor is in the Himalayan towns, the source of water is from the centralized water supply system. In urban areas, we have municipalities. So municipality is the alone the authority who supply water to the households, residents in the town. So in Darjeeling, it is it is unfortunate to see that more than 60% of the households lack official water supply. So they are forced to depend on other alternative sources. And for this region, the question of water security, urban water security, is very significant in this region. So this is the location map of our study area. So here, 4 major municipal towns of Darjeeling Himalaya have been selected for this study. And one is Darjeeling, another one is Kalimpong, Mirik and Consortium. And the objectives of our study is to understand the aspects of water security, encountering the issues of water crisis in the Eastern Himalayas. And second is to know about the current situation of water security, or the aspects that controls water security in the Himalayan towns or the urban centers. And the third is to come up with a feasible and sustainable water management system in the town.
Aashish, sorry, so we can't see your slides. We can just see the first slide only. Yeah.
Oh, I'm so sorry, sir. So is it visible, sir, right now?
Yeah.
So
yes.
It's a map, so location map of the proposed study area. Is this a so for smooth internet? I'm using actually mobile data. So for smooth internet connection, can I with your due permission, can I close my video, sir?
Yeah, definitely.
Okay, sir. So is my screen visible, sir, right now?
Yes.
So is this the map, location map of the proposed study area?
Yes.
Okay, sir. So this is the location map that I had already discussed. So here 4 major urban centers have been selected for the study: Darjeeling, Kalimpong, Mirik and Consortium is already discussed. And objectives also. So can you see the next slide, sir?
No, we can't.
Oh no. So that
we
means
have to click on it, maybe.
Yes, sir. It's changing here, but I don't know.
Oh.
Maybe it's internet problem, sir. Sorry for the inconvenience, sir. It's because of this internet issue.
Yeah, that's fine.
Extremely sorry for this inconvenience.
I mean, I guess you can just speak.
Okay. So is it changing, sir, now?
No, we are still seeing the map only right now. The map, but you can just move ahead with your slides. Yeah. No.
Okay. So, sir, so is this the?
Oh yeah. Yes.
Yes, sir. So is this the methodology, sir?
Yes.
Sir, slide, sir.
Mm-hmm.
Okay, sir.
Yes.
And for the methodology, research methodology, we have used both primary and secondary data sources. And for primary data sources, we have done some field-based surveys, focus group discussions to collect the data from the ground reality, because huge data gap can be seen in terms of water management, in terms of study related to water and other aspects in Darjeeling. So we are using this both primary data sources and the secondary data sources. So in the secondary data sources, mostly the research literatures, maps, satellite imageries, these have been taken, and municipal reports and census reports have been used to form database for this study. And here we can see like the major, so when we talk about, when we have to talk about the urban water management system, it is essential to know about the demography structure of the urban centers. So if we see here, so the census 2011 of Indian census 2000 has identified total 12 of which Darjeeling is the largest one, Kalimpong, followed by Kalimpong, Khorxing, and Mirik. And these are the ward-wise map of the 4 selected municipal towns.
So you need first to move to that slide, or
okay. Oh, yes, sir. Yes, sir. I have already moved it, sir.
Oh, okay.
So it's not visible there, sir.
Yeah, it's
so
not visible, but
ward-wise map is not visible.
No.
The ward-wise map is not visible, sir. Is it visible right now, sir?
No.
I don't know what is happening.
Yeah, yes.
It is visible now.
Okay, sir. Okay, then, sir, I think it's better to use in this way, no, sir? Is it visible, no, sir?
Yes.
So wide-wise, so these are the ward-wise map of the municipal, of the select municipal towns. So 4 municipal towns have been selected to study the urban water security of Darjeeling. So first one is Darjeeling, and it is the largest municipal town in the Darjeeling Himalaya, and has got 32 municipal wards, and followed by Kalimpong, and it's also a very large municipal area in the hill towns, and followed by Khorxing, and the youngest, the Mirik, and it's got only 9 municipal ward, and the population is also, as already shown in the previous slide, the population is also decreasing in this way. And here the elements of water governance and supply system in Darjeeling Himalayan towns. And when we talk about the water governance system in Darjeeling, water supply and governance system, in Darjeeling, the water governance is divided into 3, like independent sectors. We can call it as sectors. And first is controlled by the municipality. The centralized or the public water supply system is controlled by the municipality or the public health engineering department. And the second is private water sources, private water vendors, like the privatization is also very actively working in Darjeeling town, in the Darjeeling Himalayan towns. And the third is like Samaj, and it is a vernacular local term. Samaj is like a community-based social organization, and that is formed to help the people in time of need of ours. And municipality, we have our field survey. According to the data collected from the sampled field survey, we found out that 60% of the people only the 60% of the people in the town are actually dependent on the centralized public water supply system. And they are supplying water from the lakes and tanks through public hydrants and domestic pipelines, and these are the centralized water supply system. And moving to another part is like the community-based organizations. They have formed community springs, the springs which are not in control of anyone, and the community themselves are controlling the springs, and they are distributing water from these springs, collecting in the tanks and distributing them with pipelines and all. And the third one is the private water vendors, and these are the private sectors who are supplying water from the private springs or the private water sources, the people who have got water sources in their land, so that landowners can be considered as the owner of that spring, and they are also selling water through the pipelines or water tankers in the town. So that means the governance of water is working, and the most interesting fact is this, like the centralized or the governmental side, they are not interfering with the other sectors of water supply system. Like they are not like interfering with the private water supply system or the community based water supply system in the town.
Okay,
So in
Aashish,
terms
you
of,
have 3 minutes remaining, and we are still in the word map slide. You probably need to click on which slide. Yeah.
Oh, extremely sorry. So what is happening? I don't know. So is it possible, sir?
Yes.
So I was in this slide actually in the
Yeah,
last
that's fine.
discussion.
Mhm.
So now am I moving, sir? Is the slide moving?
Yeah, you have to click with the
Okay.
mouse, then it moves. Yes.
Yes. Actually, actually, its slide is moving in my this
Okay.
laptop, but I don't know.
Okay.
So the quantity analysis. So when we look at the quantity of this, so the demand is always high. Demand is always high in almost in all the municipalities, and as compared to the supply, so demand is higher, and so water deficit can be seen almost in all the towns. Darjeeling, Kalimpong, and Khorseng, and this water deficit is to some extent being managed by the alternative water sources like local water sources, and where the natural spring are the major source of local water, and so when we talk about the quantity, so this is the data collected from Darjeeling municipality, and likewise work has been done from other municipalities as well. So we can see of the 10 samples, the water discharging capacity of the springs are shown in this graph, and highest water discharging can be seen in the month of July, and in the month of this September, in the month of August. So during rainy season only people are getting maximum amount of water. Other times people have to struggle for the requisite amount of water in the town. And here, and the next slide is about when we talk about the security of water. After quantity comes the quality, and we try to analyze the quality of water from the different springs, and we found that the water from all the springs are highly contaminated with microbial, microbial contaminants, and we have basically found a total coliform and fecal coliform here.
You
and
have 30 seconds remaining. 30 seconds.
Okay, sir. Okay, sir. I'll try to. So this is the pathways. It's not so important. So basically, this is the work that I have done in my research work. So I have tried to calculate the water security index by using 35 parameters, and also by using the pressure index and pressure PSIR framework, that is a pressure state impact and response framework. And PSIR framework, it's a very common framework to assess the intensity of resource management in general and water in particular. And sir, is it visible? My next slide, sir.
Yes, but you need to end your presentation, Aashish. So wrap it up. We're
Yes,
out of time. Yeah.
So I'm going to the final this part, sir. So here we can see the ranking of the town. On the basis of this course, we found out that the categories, we have found out the 5 major categories: water, very insecure, around acceptable threshold, and secure and very secure regions. And we found out that with the data collected from the field, we found out that Mirik and Khorseng are at around acceptable threshold, and Kalimpong and Darjeeling are at water insecure region, and these are done on the basis of the data collected from the field. Thank you, sir.
Okay, thank you, Aashish.
Sorry for the inconvenience, sir. My internet is very weak today. I don't know what happened.
Okay, so here one suggestion by Dr. Keshav Trai says that your research is interesting, and you might want to look into the theory of hydraulic civilization and ecosystem services. It's there in the comment. Just take a look. And
okay, thank you so much, sir. I will definitely take
could develop a good water use model using the ecosystem service idea, right? So this panel will close at in 2 minutes, right? So, but I guess in the last 2 minutes, if no one has a question, you talked about water governance. What is the problem with water governance? What is required to solve water governance problem? Can you briefly talk about that?
Yes, sir. So when we have to talk about the water governance, the most important thing is like in Darjeeling, the water sources are not being controlled by the particular or the organized form of governance. So the entire water is controlled by three independent three independent authorities. Like one is centralized public water supply system is look after by municipality or the government agency, and at the same time they are neglecting the other local water sources, alternative local water sources, and as a result of which the centralized public water supply system is not being able to satisfy the whole water demand in the town. And the people are also forced to move on because the supply is limited from the public water supply system. So people are moving towards private water supply system. So in terms of governance, private water supply system, they are collecting the water from private sources, private springs, or private, and they are selling it at higher cost. So here we can see the governance side, the no government agency are taking care or trying to control the private water supply system. Why the private sellers, they are costing high charge on the basis of their interest, and no restrictions are there. So water supply system, so governance are to some extent neglecting in recognizing the local water sources and augmenting the local water sources in areas. And on the other hand, community organizations, Samaj and community-based organizations, they are trying to establish some fairness in the society, and they are supplying water, they are managing the water sources, local water sources, and are supplying water at free of cost to the society. So in a way, the government is not trying to intervene the private water supply system, or they are not assisting those who are working fairly in the town. The community organizations, Samaj, they are trying to provide water freely